Hello, so precision and accuracy, they are actually different, you know. So what is the difference, yeah? Suppose we have two students, both conduct an experiment to measure the value of g, the acceleration of free fall. So this is student A's measurement, this is student B's measurement. Whose measurement is more precise? If you're talking about precise, then B's measurement is more precise. That's because he has an uncertainty of only 0.02, which is much smaller than student A's uncertainty of 2, right? 2 meters per second square. So B is a more precise measurement. As for accuracy, student A's measurement is more accurate because his value of 10 is closer to the true value of 9.81 meters per second square compared to 9.31. Yep, get it? So roughly speaking, precision is about small uncertainty, yeah? Having a small uncertainty. But accuracy is more about whether you got the correct value or not. Okay, another example. So let's say we have two companies, both of them are producing wires of diameter, let's say 1 mm, yeah? So we collect samples from the two companies and we plot their diameters in a histogram. So this is company A's distribution, this is company B's distribution. So which company produces wires which are more precise, yeah? More precise. So precision-wise, company A's wires are more precise. The reason is because the spread, right, in the diameters is much smaller than the spread in company B's wires diameters. So A is more precise. As for the accuracy, that depends on how close they are to the intended value of 1 mm, isn't it? So if 1 mm sits here, let's say here is 1 mm. If that's the case, then B is actually more precise because its mean value is here. And the error, right, the deviation is this much. Whereas company A's wires mean values are here. So it has a much larger deviation from the correct true value. So when it comes to a data set, a population, yeah, then precision is about whether you have a small spread among the data. Accuracy is about the deviation between the sample's mean value and the correct value. Okay, one more example. Let's say we have two students, both of them apply a voltage V across a resistor and then measure the current and then collected 6 data points and then plot the best fit line and so on. So the gradient of the line is supposed to tell us the resistance of the wire, right? The resistance of the wire. So which student, so let's say this is student A and this is student B. So which student has a more precise experiment? More precise experiment will definitely be student B because student B's data has practically no scatter, right? No scatter, whereas student A, his data shows a considerable scatter about his best fit line. So B's data are much more precise. The best fit line is very well defined, huh? Whereas A's best fit line is somewhat ambiguous. So let me write down here first, precise. As for accuracy, again, that depends on whose result gives us a value that's closer to the true value. So suppose that the dashed line here is supposed to represent the best fit line if for the correct true value. So if that's the case, then A is actually more accurate because his best fit line is closer to the true or theoretical best fit line. Alright, that's all. Ta-ta!